with this plugin Condor supports. So you can use, Archie, Gopher, HTTPS, whatever. So that can be helpful, even if you have thousands and thousands of machines, right? So one thing that people do. This is kind of clever. I don't know if there is any chalk. There is no chalk.
Is it under the eraser?
Oh, yes, it is. So let's say you had a really big Condor pool, and you're submitting from here, and maybe you have the computer science department, and it had a zillion machines, and you had engineering over here, and it had a zillion of machines, and you had whatever, chemistry over here. So one thing you could do using the HTTP plugin is you could fire up Apache or some web server of your choice on your machine, and when a job lands here, a Condor will use HTTP, pull it from your machine, and that would be one way to do it, right? This doesn't buy you much over what we showed the first time around, what Frida does. But a nice thing about HTTP is it's designed to work with proxies, right? So you could install. Anybody use Squid? Anybody hear of Squid? So Squid is a really common web proxy cache. Okay. So what if each department had a Squid server sitting at the front of it, and you set up your job to pull its data via HTTP to its local Squid server. So this guy, the job will fire up here and say, give me Todd's file foo from this server. If this guy doesn't have it, he will go out to my web server running on my machine, pull it, but then it'll cache a copy here. Right? So all the other hundreds of jobs that start up in computer science aren't going to come all the way back to my machine. They're going to pull it from this guy. Right? So we have a lot of some big organizations that use Condor kind of take advantage of their web caching infrastructure for their data infrastructure as well. HDFS. Anybody hear of Hadoop or the Hadoop file system? HDFS stands for the Hadoop file system. So some woodpecker has heard of the Hadoop file system. So there's a couple really popular papers that Google published a long time ago. One is called the Google file system, and the other is called the Google MapReduce system. And basically these two technologies were kind of a big part of the secret sauce when Google first started up of how they did all the indexing of the web. Small plug for UW-Madison, Go Badgers. These papers had very few citations in them, which for research papers means either the authors didn't do a good job or everything we thought of most things ourselves. I'm not sure which it is, but the point is there were only about 8 citations, and I think in the MapReduce paper, 3 out of the 8 were all from UW, cited work at UW-Madison, and of the file system one, I think 2 of the 6 or something were from UW-Madison. So who knew? Hadoop file system is a block-level distributed file system. So what you can do is you have zillions and zillions and zillions of machines. Let's pretend each one of these machines is running Condor. Let's pretend each one of these machines has a disk attached to it, of some local hard drive, which is true of most machines now. It's also true of most machines now. I mean, you can't even buy a hard drive anymore with less than 160 gigs or something like this, right? And I know in Comp Sci, most of that is sitting there spinning empty, right? I don't know about CAE. I don't know. My disk is pretty full personally, but anyhow, what the Hadoop file system does is it has one machine that keeps track of all the files, and the blocks for the files instead are distributed out across all these disks. So you can kind of think of it as striping doing black level striping against all the machines. Okay, and there's a few things involved. One, there's a replication factor. So each block isn't written to just one machine, but typically you say, I want each block replicated 3 times. So the block will, block 1 will go, here, here, and here. Block 2 will go here, here, and maybe here again. And the idea is when you have thousands of machines are, Murphy's Law. Some of them are going to be down, some of them are going to be off, some of them are going to be gone. So as soon as one machine with a block disappears in HDFS, it's replicated to another. So it actively tries to keep always, say, 3 copies, right? So another plugin that we have with the Condor file transfer is to use the Hadoop file system. And in fact, in current version of Condor, one installation option is when you install Condor, it creates a distributed Hadoop file system for you on the fly. So this would be one way to get around the idea that I'm going to have thousands of machines and terabytes of data and this and that. So I put a maybe yours here as a shameless plug to maybe you guys want to write a data plugin. It's easy to do. So I think there was a student as a class project did a BitTorrent plugin. Pretty cool, not bad. So your submit machine just becomes the tracker, and then it's nice. Condor's running these jobs, and let's say Frida's organization just bought a dedicated compute cluster, right? So this is how things look now with her jobs running. And we'll talk about another universe, the parallel universe, nonetheless. But now that she has a lot of nodes and a dedicated cluster, she could start submitting jobs that require more than one node. So who here has ever heard of, say, MPI? Practically everybody. So MPI would be one example requiring Condor's parallel universe. And it looks a lot like the vanilla universe with the small difference that you just give a machine count that says how many machines you have. MPI isn't the only type of job that would want a parallel universe. For instance, Condor is used by a lot of places, including us, for software development. Okay, so compile jobs are Condor jobs, and then testing, regression testing is a huge problem. So on Condor alone, I mentioned it's kind of half production, half research. So we have about 17,000 regression tests that we run every night on Condor, and kind of the do the daily build and test run, right? And parallel universe is also very useful for testing. Maybe you're writing a web server. You want to do scalability testing. I need 100 machines, and I'm going to stand up my server on one of them, and I'm going to have the other 399 pound on it, right? So a little bit about the Condor daemons. If you actually did a PS on a machine running Condor, what would you see? What do they do? One daemon is called the Condor Master. See, now you guys get the little geeky joke on my shirt. One daemon is called the Condor Master, and this is essentially the administrator's front. It handles administrative tasks like, you can now sit at one machine and do Condor off minus all, hit enter, and Condor turns off on all the nodes, or turns back on, or what have you. The master is also the parent process of all the children. So the master is also responsible for starting all the other Condor processes, make sure they're running. God forbid if one of them should crash, which of course never ever happens, except Murphy's Law says it will. It'll send email to the administrator and restart it, and this kind of thing. The collector, think of it as a database of class ads. Okay, so you got all these machines out there, and the collector is the place that collects all the information or all the class ads about the resources that are out and about. There's the Condor negotiator, which does the matchmaking. So this is the process that actually matches up job ads and machine ads. So it's sitting there alongside the central manager. There's the Condor start D, and this process represents a machine in the Condor system. So it enforces the policy of the machine owner. Only run jobs from my friends, or only run jobs at night, or only run jobs when nobody's typing.